will be our third sort of mini talk on relational math. So we're querying databases, and so in relational databases are basically comprised of tables. So when you hear relation, think table, and relational math is just things we can do with tables, things that can result from querying and combining tables in various ways. So we talked about selecting and projecting. We talked about uh, unions and intersections and set differences. And now we're going to make our way to the sort of common way to combine tables, and that being the join. But we're going to sort of like work a little bit with the precursor to a join, which is the Cartesian product. So here we go. All right. So a Cartesian product, if I have two tables and I make a Cartesian product of them, I'm going to sort of make a concatenation. So I'm going to put a row from table A next to a row of table B. So I'm going to have a very long row. And then I'm going to do this for all possible combinations. So every every possible combination of a row from A and a row from B are going to go and together and make this Cartesian product. And it's not a very useful thing, but it's a step on the way to a join, which is a very useful thing in relational databases. So here we go, the Cartesian product. So it's going to be a very big thing. So let's understand sort of how big it's going to be. So let's imagine we have these two tables, and let's keep the data simple and just have letters. So I have a table that had three properties, and I had four records. So my number of properties was three. I'm over here on the left. And so we'll call that the degree. And then we had the cardinality. How many records do we have? And we're just going to keep it simple and have four. And then I have another table, and it has a degree of two. It has two properties, and then it had five records or five rows. So it's had a cardinality of five. Now we're going to concatenate uh, the first table and the second table, a row from the first table and a row from the second table. So it's going to have a degree of five of the degree of A plus the degree of B, because every column is going to, every column from A is going to appear and every column from B is going to appear. So that's going to be altogether five columns, or I'm adding the degrees. And then as I match up, I do all possible combinations. Then for every row in the first table, I'm going to match it up with all the rows in the second table and do that for all the rows in the first one. And that's going to be, then the cardinality is going to be the product. So I'm expecting here, if I were combining these tables, to end up with a degree of 5 and a cardinality of 4 times 5, or 20. So here is this big mambo thing. Okay, so again, this is the Cartesian product. You just simply sort of concatenate the rows from both tables and do all possible combinations. Okay, so, but these, I mean, that's a mathematical operation, but a not very useful one. And so, but let's turn it into something useful. So our tables, our relations, somehow corresponded to entities, and those entities have relationships. And at least with a simple one-to-many relationship, this is sort of easily realized with the relationship is realized by having a foreign key from one table match a primary key from the other table. So we have values from the same domain, from the same set of values. Okay. So I was working previously with this Simpsons little database. And so a character we assumed was voiced by sort of one real person. So then we could put that person's ID into the character table, and that would realize the relationship between the real person and the character, and that make that relationship of that real person voices that character. Okay, and so here's just that sort of diagram of that little database, and we see there the real person table, the character table, and they share person ID. So character ID is the primary key of character, but it also has person ID, which is a foreign key relating it to the primary key person ID in the person table. Sort of a standard relational database affair. Okay. Now, if we make the Cartesian product of character and real person, then we're going to take all the properties that a character has and all the properties that a person has and just make them in all the possible combinations. And so we will have rows that really have no business being together. That there's a row of a person concatenated to the row of a character, and that person doesn't voice that character, has not necessarily anything to do with that character. Okay. And so as we begin to sort of, we want to sort of focus down on the actual relationship, then we're going to add a selection. We're going to filter down and find out, of those set of properties that we sort of had in, as we added all the properties of both tables, there are certain rows in which the person ID from character and the person ID from real person will match. So we can add a condition and a predicate, and then we can collapse down this monstrous Cartesian product and make it into what we call a join and make it be useful and sort of correspond to our relationship, in this case, of real person voicing a character. So here was my ugly picture. Now, if I go back and look at this table a little more carefully, I can think of, I have in my first column in the first table, on the table on the left, my values are A, D, G, and J. And I have those in the first column of the second table on the right. Also, they are pulled from the same domain. I have A, G, D, D, and J. So they are from the same domain, so I can use them to establish a relationship. I can imagine maybe in that second table, those are foreign keys. That has to be, if one of them is the foreign keys, it has to be the second table. Those are the A, G, D, D, J. Those are the foreign keys because they couldn't be a primary key because I've duplicated the D. So that would make no sense as a primary key. But I'm so imagining that first column of the first table is primary keys and that first column of the second table is foreign keys, and I want them to match up, then we're making a join. And so I highlighted those in yellow. Those are the ones where those two columns match. So if I add a predicate, if I add a condition, if I do a selection, then I'm getting rows that are sort of relationship meaningful. And so here we are after the selection. Now you have two identical columns, and you probably wouldn't want that. So on top of your selection, you're going to add a projection, and you're going to get rid of at least one of those. That right now the first and the fourth column are identical, because that's what we pulled out. We only wanted the rows when they were identical, but now we have these identical columns, so you certainly don't want that. So you would throw at least one of them away, and you might throw away both of them. You might say, I've got no business. I don't have any interest in the IDs other than them establishing for me my relationship. Making sure things are unique and establishing my relationship, but I don't necessarily want to see them in my results. So I may get rid of both of those columns. I'll certainly get rid of one of those columns, and that would be projection. So here I'm showing just projecting out. So making the Cartesian product, adding the selection, adding the projection. And so when we've combined the Cartesian product and selection and projection and put all those together, we have the idea of a join. So we've played with joins before, but now we're just sort of making them, starting off with just basic sort of things you can operate with tables and selection and projection and Cartesian product, and sort of establishing a join as just a combination of these other operations. So here is sort of a real person table. So in my real people I had a credential table. Some people had credentials. And so the people had a ID, and there was a credential ID, and then there was a person has a credential ID. So there it is, a person ID. You see, Access is doing something for me where, as it says, it's person ID. It's not showing me the ID in the foreign key, but showing me the name of the person. A database, a good database management system will often sort of hide the foreign key and give you the more to a normal person, a more meaningful thing. But these really are person IDs that match the previous person IDs over here in the person table. It's just not what Access has chosen to show you, but what's really there hidden behind in the real database system would be person IDs. And if we make the Cartesian product, I will be relating credentials to people who don't have those credentials. And then I'll finally need to do the selection to get the Groening's credentials associated with Groening and nobody else. So here is just this crazy thing of all the possible IDs, all the different people, and all the different credentials. And so this is not my relationship at all. I just made this crazy thing in Excel. But then I did this match and got it down to, okay, now I have the person and his credentials. Okay. Now I threw out a bunch of people here because I was lazy and I didn't give everybody a credential, or maybe I was giving awards and maybe not everybody's won an award. And so then we have to start talking, not now, but another time, about different types of joins. So what do we do? How do we get a person who didn't have a credential? How do we do that in joins? So we have to make fancier kinds of joins, but another time. Thanks for your attention.